12:15. That way that can give you guys about 15 minutes to ask any questions you may have. All right? Cool. So let's go ahead and start. I'll go ahead and post the first page of what we're going to be working on, and tell me, can you see this pencil okay? Can you see that pencil all right? Yeah? Okay, then I'm going to write with pencil because I don't like doing math in pen. I'm sure a lot of you don't. Okay. All right, so our first problem asks us to evaluate, you guys get that? Evaluate this integral. So this is our integral. X to the 5th, 25 minus x squared dx. So this is what we see first. First we see this 25 minus x squared looks very familiar, right? If you try use substitution, you end up getting like negative 2x. Can't use u sub because you still have an x cubed left over. So you have to end up going to trig substitution. These are your trig sub equations. These you should memorize. This cheat sheet will not be given to you on your final. So please know this like the back of your hand. As we go through, I'll be going over different things we need to know over this cheat sheet. It will also be posted on the Study Union WordPress website, okay? So which one are we going to use for this one? Because it says, it looks like a squared minus x squared, so we're going to use x equals a sine theta, okay? As our u. No, I'm sorry, as our x. So x equals 5 sine theta. And then we're going to take our dx, which will give us 5 cosine theta. Then we just plug in. You get 5 sine theta. And then that gives me 25 minus 25 sine theta. If you get stuck, please raise your hand so I'll know where to stop, okay? No questions so far? In here, we replace our dx, sorry, I forgot a d theta, with our d theta, or with our 5 cosine d theta. I ran out of room, so I'm just going to write it down here. And now we have our equation in terms of theta, so we can evaluate it, okay? All right. And if you can't understand something I'm writing, please let me know as well, so I can clarify. So I'm just going to pull out my constant, and that's going to be 5 to the 5th. I don't feel like evaluating that right now, but we will towards the, well, you don't really have to towards the end. So then you get sine 5 theta. And this, we can pull out a 5 right here, and that gives us 1 minus sine squared theta. Your trig identities. This one you should know. You should also know this one. You can transform this one into this one by, if you ever get stuck and you're like, what's the tangent plus 1 equals secant squared? You can just divide the sine squared plus cosine squared by cosine. And by cosine squared, and it'll give you all the equations you need, okay? So you can take this out. 1 minus sine squared theta we know gives us cosine theta. So we can go in and evaluate that. I'm going to pull this 5 out over here to give me 5 to the 6th. And what I'm going to do real quick, and I'm also going to pull out this 5 to give me 5 to the 7th. Now what I'm going to do here, please don't get confused by this step. I'm going to pull out one of my sines because I also have another trig identity that can give me something for this sine to the 4th, okay? So now I got this one equals cosine, and then I also have another cosine theta d theta. Now I have, this is why I don't like using pen because I keep erasing. Now I have I can simplify this to this, clear? And make this sine theta cosine squared theta d theta. An identity for my sine squared theta, where I'm not backtracking, is 2 cosine squared theta minus 1. Right? No, I'm sorry, I'm looking at the wrong one. Oh no, I am backtracking. Okay, so I'm going to do this. Sine squared theta, as we've seen from this, will equal to 1 minus cosine theta from our identity squared times cosine squared theta sine theta d theta. I just switch these around so I can look at what my u substitution will be, okay? So my u, it looks like can be cosine because when I take the derivative of cosine, I end up getting negative sine. Clear? All right. So I'm going to put my u's over here so there's no confusion. Cosine theta. So my du is going to be negative sine theta d theta. All right. So now I have negative du equals sine theta d theta. Just plug that in. So now I have 1 minus u squared squared times u squared times du, but I need to pull that negative out to the front. Please don't forget that. Whatever constants or negative you have to pull that out. All right? Negative 5 to the 7th times u to the 4th minus 2u squared. This is just our basic algebra. Plus 1 u squared du. Negative 5 to the 7th. And just simplify this so we can go on to take the antiderivative of this. And then that gives us times, add 1, divide by the number, u to the 7th over 7, add 1, negative 2, u cubed over 3, add 1 plus u cubed over 3. But unfortunately, we are not done yet. We still have to plug in our u's, and then we have to take it back to our x's. There's a simpler way to do this. Let's just keep on going. Oh, yes.
Can you take it back a little bit? I feel like I got lost a little bit earlier.
Okay, where'd you get lost at?
We did the trick. So back to like 5 to the 7th, sine squared, sine theta, cosine squared theta, d theta.
Right here?
Yes.
Okay, cool. So to explain it in easier words, when I went in and I plugged in everything, what I did to learn this, I just simplified everything and looked at what I had. So basically wrote it all out as I did here. This looks kind of messy right here, so please just know that that's supposed to go right there. So this sine to the 5th, that's what I ended up getting when I simplified everything. I took out this 25, and that gave me 25 times 1 minus sine squared theta. And then I took the square root of that 25, pulled that 5 out, all that great stuff, right? So I'm left with my sine 4. But sine to the 4th is also equal to sine squared squared, right? Because when you multiply two exponents, when you're taking an exponent to a power, you multiply those exponents. So that is the same as that. You see that? But to give me sine 4th instead of sine 5th, I just pulled out a sine theta because I need it to be even because I don't really have a trig identity for a sine odd. Clear? All right. I also have 2 cosines left over here. One of my cosines is because 1 minus sine squared theta is equal to cosine squared theta, and then I take the square root of that, which is cosine. And then my other cosine is left from my dx, right? So then I put those together. Well, I kind of simplified that, and I put my 2 cosines together right here, and I still have a sine theta left over. But if I were to try to evaluate from right here, and my u was sine, my du would be negative cosine, but I still have a cosine left over. So I know I have to keep going some way, somehow, right? So I transfer this into cosines, so I only have one of the sines left over. So I need to have one of either the sines or cosines, and I can have multiple of the other because I know if I take the derivative, then I'll just still have that one for my du. Does that make sense? Not really? When I'm right here, I can't really do anything because I have multiple of both sine and cosine. And when I take the derivative, I can't get like cosine squared and all that stuff, right? So I need to end up having one of one, and then I can have multiple of the other. So when I go to derive and do my du, cool. And then from there, I just do u sub and just simplify on. Yes?
I don't want to play problems, but in the second integral from the bottom, wouldn't it be equal to u to the 4, not u squared?
Where?
Down below, because you distributed the u to.
Thank you for catching that. Thank you so much. All right, disclaimer, I'm not perfect. I make mistakes as well. So if you catch something, please let me know. But thank you again. So yes, that is 2u to the 5th over 5. Any more questions? No? All right, so we'll keep going. Okay. Oh, sorry, that was really loud. What I usually do from here is I draw a triangle that gives me my equations. So I know I base my triangle off of my original x, okay? So sine says, so basically the sine is opposite over adjacent, x over 5. So the opposite of this is this is 5. And one thing that you'll see is every time you go to draw your triangle, your end that you're missing is always going to be whatever you subbed it for. So you don't even have to go through and do all that a squared plus b squared equals c squared. You're just going to know that it's that because that's what you got it from. So 25 minus x squared. And I know my u here, so I have u in this equation. This is my final equation. And I know my u is equal to cosine theta. So that means all I have to go through and do is take the cosine theta of my original triangle. Cool? Instead of going back and doing all that extra work and plugging in u, and then that's just too much. So we're not going to do that. So my cosine theta is equal to square root of 25 minus x squared over 5. Yeah? Okay. So then you just write that out. It's x squared for 5 to the 7th times 1 to the 7 minus 2 is going to be a really big problem. 25 minus x squared over 5 to the 5th. And I'm just going to bring this down right here. Hopefully, I'm going to try to post the solutions cleaner so you guys won't really get confused. So I may just go ahead and go through and rewrite them. Cubed times 1 over 3. Plus c. Do not forget that. I know some of your professors, if not all, will take off points for that. So please remember your plus c, because this is an indefinite integral. Clear? Yes? Oh, I thought you. Oh, yes, sorry. Any questions? Let me know when you're done writing and I'll move on. These are also going to be posted, by the way. Can I move on? Silence, so I'm going to take it as a yeah. All right. So that was really A, so let's go on to B. B says evaluate this integral right here. X plus 1, x squared plus 2x. Our first problem is we can't integrate something to infinity. So we have to go through, sorry, my stuff is messed up here. We have to go through and take the limit as b approaches infinity. from 1 to b of x plus 1 over x squared plus 2x. From here, I look to see, my first thing is, can I evaluate using u sub? Turns out I can. So we're going to pose our u as x squared plus 2x. Our du will then be 2x plus 2. It looks like at first you're like, well, I can't put that there. But in reality, you can, because du, once you sub a 2 out, it looks like this, right? Oh, dx. Please don't forget that, y'all, because I forget that at times. And then you can just divide both sides by 2. So then you get 1/2 du equals x plus 1 dx. And that goes on to give me the limit as b approaches infinity, 1 to infinity. So my bottom is my u. Oh, I have a 1/2 outside, so don't forget your constants. Du. The limit of 1 over u is ln of u. Not the limit, the integral, sorry. One to b. Clear so far? I'm gonna take that as a yeah. So then I just go through and sub. Oh. Infinity, 1/2 ln of, my u is x squared plus 2x. 1 to b, then I evaluate. Ln of 1 minus 2. I know an ln of a negative does not exist. Oh, that's not a negative. I'm sorry. That's ln of 3. And when I take the limit, and does everybody see when I take the limit as b approaches infinity, this goes to infinity, right? And this is minus ln of 3. But because this diverges, the whole thing diverges, so it's a divergent function. Cool? Clear? Therefore, no questions? Okay. C. Evaluate this function. X minus 4 d. That's the square, that's the cube root, by the way. It's just my divide sign and cube root sign get in the way. All right, so for this one, it kind of looks like an easy one until you realize your limits. It goes from 0 to 5. This function is discontinuous at 4. If you put in 4, you end up getting 1 over 0. That's undefined. That's unacceptable for an integral. So we have to split it up and then take the limit as from 0 to 4 as it approaches from the left, and then from 4 as it approaches from the right to 5. Cool? I'll write that down just in case you did not catch that. Well, first let's split it up like this. Dx plus 4 over 5, 1 over minus 4. So this is how we have to split it up because it's undefined at this point. Now, if it were undefined at 2 points, then you have to end up doing 3 integrals. Both with your bounds that are the ones that's undefined. So let's keep going. Here, I can do u substitution, but I'm going to start with this one. Oh no, I can just do both at the same time. So my u, I'm going to set as x minus 4 because I know my du would just equal dx. But as I said, it's undefined at 4, so I'm going to have to sub those for A and B. 0a, 1, 2, x minus 4 dx. I got to take the limit, sorry. As A approaches 4 from the left. So don't forget this, because I almost did, so don't forget your limit that you're taking it, because it's undefined, as I've said. And then this one, you're taking the limit as B approaches 4 from the right. So you're trying to get as close to that point as you can to see what it's acting as before you actually hit that point, okay? B to 5. All right, so now I just go in and plug in my u's, but I'm going to start with my 4 from the left. Zero to A, 1 over u cubed du gives me 0 to A, u to the negative 3 du. Add 1 and divide by it. So that gives me u to the negative 2 over negative 2. Yeah, you're right. You're right. I did something wrong. Wait. U to the 1/3. Yes. Is it supposed to be u to the 1/3? My mind is like, oh, because it's cubed root. Yes, you just said that. Okay, thank you, thank you. I went blank for a second. I'm sorry, y'all. All right, so now add 1. 3 over 3. That gives me 2 over 3. So u to the 2 over 3 times 3 over 2. 0 goes to A. A approaches 4 from the left gives me 3A 2/3 over 2 minus, that's really just going to go ahead and give me, oh no, I got to plug back in. So plug back in for your u, x minus 4 to the 2/3. Yes, sorry. 0 to A. 3 times A minus 4, 2/3, 2 minus. Any questions so far? No? Okay. So now I just go ahead and plug in my 4. That gives me 0. This right here gives me negative 3 times negative 4 to the 2/3 over 2. Now I have to go on to take the integral of my next function. So the limit as B approaches 4 from the left. That's not an integral sign. Yes. Can you see both? No problem. Okay. That's B to 0. B approaches 5. Basically the same thing. So I'm really not going to rewrite all that stuff because it's the same work. So I'm just going to go ahead and plug in 4, 3 times x minus 4 to 2/3 over 2 from B to 5. And that gives me 3 times 1 to the 2/3 over 2 minus 3 times b minus 4 to the 2/3. Oh, what's wrong with my paper? Okay. Sorry, I'm just gonna have to write around that for a second. Can y'all see that okay? Although I have like a really nasty wet mark. Over 2. So when I evaluate that, that gives me 0 because we plug in my 4 for b. 0 times everything is 0. And so this gives me 3 over 2. Now, we go back to this. We've seen here that to actually get, to find the function, we add these two limits. So I'm adding -3 times -4 2 cubed over 2 plus 3 over 2. Cool? Sorry. Yes.
Sorry.
No, you're fine.
Back to question 1A a little bit.
Okay.
Was the thing that we plugged in root 25 minus x squared?
Oh, like 1A, the problem. I'm sorry, what were you asking?
Yeah, the problem. The thing that we plugged in at the end, was it root 25 minus x squared?
Yes, it was root 25 minus x squared over 5, because that's what I have for cosine theta, and that's my u. That's completely fine. I always told the students that came to my SI session, it's your exam, not mine. So if you have a question, ask me. All right. So that is what we get. You can further simplify this just a little bit, but it's up to you. All right. So now we are on D. What are we at? 2x plus 3 times x minus 1 x squared plus 4. This is also on our little, I'm going to put my scratch right there. Things to remember sheet that I put for you, that I'm going to put up for you guys. Partial fraction decomposition. This is what it looks like if you forgot. If I have just a regular polynomial, a over that, b over that polynomial, but if that polynomial is squared, then I have to repeat it using a different constant at the top. Cool? If that polynomial has a squared on the inside, then I have to do a constant x plus a different constant. See that? All right. So that is what we're going to use for this one. Can't really use u sub because that goes to 1, that goes to 2x. And if you plugged in that u, you still have this. It's just really messy. You can't do it. So looking at the rules that was just put up here, I know that has to be a over x minus 1, and that this has to be bx plus c over x squared plus 4. Okay? So the way I do this, some people do it differently. If you do it differently and you end up getting the same answer, by all means do it that way. But I just set my numerator of my integral equal to ax squared plus 4 plus bx plus c times x minus 1. And then simplify that. Ax squared plus 4a plus bx squared minus bx plus cx minus c. And then I just set whatever constants on this side, or not constants, but terms on this side with like terms on that side. So I have no terms on this side with x squared, so that's going to be 0 plus ax squared plus bx squared. That doesn't really help, so I'm just going to go ahead and go to my other like term, 2x. Oh, I don't keep in the x's, sorry. It's easier if you keep in the, just do the constants. So on this side, it's just 0 plus ab. This is for x squared. I hope that doesn't confuse you. I'm just letting you know what constants I'm using. Then I have 2 for negative b plus c, and that is for x. And then I have 3 equals 4 minus C. All right. 4A. Excuse me. It's clear on how I did that, on what I did. Okay, cool. So I can just go ahead and just say C equals 2 plus B. And then I'll just go ahead and plug in my C right here. You just start plugging in until you find what you need. Oh, easier way. A equals negative B. Oh, not an easier way. Never mind. 3 equals 4A minus 2 minus B. This is too much. Oh, I have a function like this. Minus 3. Minus 3. A equals 1. 4 minus 2 is 2, minus 3 is negative 1. All right. Finish if you haven't, it's fine. But this is what my constants end up being. Did everybody get this? Everybody understand what I did? Just systems of equations. Okay, and then I just put those constants above the same equations that I derived from this integral. So my A is 1, so I have the integral, forget your integral signs right there. So I have my integral of 1 over x minus 1 dx plus negative x plus 1 over x squared plus 4 dx. Now I have to go through and take the integral of these. It's like a never-ending problem, honestly, but it's okay. I know my integral of this, if I do use substitution, I have dx, so really it's just the ln of that problem. X minus 1 for that. This one, a little bit different, because if you take the derivative, you get 2x. As I said, you can't just plug in 2x up there. So plus this integral. I'm going to split this integral up to look like this. Negative x over x squared plus 1 plus 1 over x squared plus 1. To make it a little bit easier to simplify. Yes, sorry. Oh, I'm sorry. Thank you. Everybody see what I did there for this one? I just split it up. And I'm going to take this negative out. It's kind of bothering me, just to make it a little bit easier. Now for this one, I can do u sub. U of that, it will be 2x. I can just pull out that 2 and my du will be x. So let's do u. So I'm going to label this 1. Put this as 1. It's x squared plus 1 du equals 2x dx. And my 1/2 du gives me x dx. So now I have 1 over u du times 1/2. Which gives me ln, or 1/2 ln of u, but I'm going to go ahead and just sub that x squared plus 1.
What happened to the 4? It was like x squared plus
Oh, you're right. That's 4. Excuse me. Thank you. Okay. Clear on that? It's just our basic integrals that we've been doing. The next one, our next integral is this. Oh, that's why I ripped it. X squared plus 4. This one is an identity, integral identity that I also put down on the cheat sheet for you guys. So please memorize this as well as the other ones that I'm about to show you right here. So this one, 1 over a squared plus x squared dx equals 1a over arctan x over a. You should know this one along with the derivative of ln of x. This one is pretty obvious. That's your integration by parts, which we'll come to, and that's your arc sine. So if you get these and you're like, I don't know how to derive this, these are ones that you should really already know, which is probably why you probably be difficult to derive it, as well as your secant x, but we'll get there later. Okay? So this one, pretty easy. We said the equation was 1 over a squared plus x squared dx equals 1 over a tangent negative 1 x over a. So this is my a squared. So really my a equals 2. So 1 over 2 tangent negative 1 over x over 2. Easy, just like that. So now I just go through, and as we've seen here, I have to add everything up. So it'll be ln x minus 1 minus, because I took this negative out right here, minus 1/2 ln of x squared plus 4 plus 1/2 tangent negative 1 x over 2. And if you want to just get really simplified, you can just take that 1/2 and do those added, but it's not really necessary for this review session. Any questions? Yes. Plus c. See? You're going to do well. I can see it. All right. So, yes, plus c. Don't forget that. Oh, sorry. Yes?
Why is there a 1 above that integral right there?
There's a 1 because I was just letting you know where I was doing my u for.
Okay.
It's just to notify you. Does that confuse? Yeah, that's in a bad spot. So let me move that. I'll put it in a box. And I'll just go ahead and put a 2 above this one as well. Yes. Yes. Are you good? Okay. No problem. Oh, I didn't do a U, but it's okay. All right, so while you guys write this down, I'm going to go ahead and start on E. All right, so indefinite integral is 5 e to the x dx. This one, again, can't do u sub. Actually, really can't do much because of that ex. The derivative or integral of ex is always ex. So I have to use something a little different. And that is where my parts substitution, it's called something, integration by parts, that's what it's called, comes in. And I'm going to use this equation. This equation you should also have memorized. Definitely have this memorized because more than likely they're going to give you a problem where you have to use this. So UV, did I see a hand? No? Okay. Huh? VDU. VDU or U prime V, whichever one you like to do. My mind just goes to U prime V, but yes, you're correct. So the easiest one I would want to use for V prime, this is how you write it. So V prime V. Just for ease, the one I would want to use for V prime is EX dx, because like I said, the integral or derivative of EX is always EX. So just for ease, you use that. And it's a lot easier to take the derivative of x squared minus 5 compared to the integral of x squared minus 5. So now I have 2x dx. All right, then I just plug in. My UV is x squared minus 5 times EX minus EX, and I'm just going to bring this 2 outside, EX times X dx. Same thing, same problem. Can't really do anything with this, so we have to do another U sub. So my U for this. One thing that you should always remember to do is don't switch it around if you have like the same variables or the same function, because then you're just going to end up going backwards. So whatever I use for my V prime, I'm going to use this my V prime the first time, I'm going to use for my V prime the second time. So EX dx gives me EX, and that just gives me dx. So now I have x times e to the x minus EX dx. So now this function is minus EX plus C. So then I just go through and put all of this great stuff together. So my final answer ends up being, please don't forget about your original, x squared minus 5 times EX minus 2 times x e to the x minus EX plus C. Any questions? Pretty simple. We went through that one pretty fast. So that one's not that scary, yes.
X squared minus 5, that's supposed to be prime.
It doesn't really matter, but to make it look better, yeah. That's just how I wrote it because I understood it, but.
I mean, like, the x squared was supposed to be multiplied by dx.
Where? Right here?
It's like on the bottom where you just.
Right here?
Yeah.
Yeah, so it's x squared minus 5 times e to the x. So yes. I guess, yeah, you're right, because if you were looking at it, you would think it was negative 5 times e to the x. Okay, thank you for catching that. So I should probably do it right here too. All right, yes? I didn't, this? Oh, this went right here. You see it? This, I realized I couldn't take the integral. I couldn't like just do U sub or anything, so I did another integration by parts on this. So this is where I did this. So in other words, this part right here, the integral of e to the x dx is equal to that. Make sense? Good question. Anybody else? All right. So now we can finally move out of our letters and we can go to a different problem. This problem states, oh, where did I put it? Here it is. This problem states this. Can you see it? Find the volumes of the solids obtained by rotating the region enclosed by y equals sine x, x equals 0, x equals pi, and y equals 2 about the x-axis and about the y-axis. So volume, rotating regions, finding the volume of rotating regions. These are, kinetic. Okay, these are my lines or my curves, as they would like to say. So I just start off by drawing them. You won't have a graphing calculator, but I'm pretty sure most of you have already gotten the hang of drawing your lines. I'm gonna number my axis by pi over 2 and all that great stuff. And my x-axis by pi and pi over 2, my y-axis by numbers. It doesn't really matter because pi is also a number, it's just in pi form. And I know my sine looks like this. So when my sine is 0, my x is 0, sine is 0, x is pi over 2. Sine of 90 degrees, that's like 1 over square root of 2. So it's somewhere under 1. So I'm just going to put it at 1. But just know that it's not at 1. I'm just putting it there so it'll look a little better. Yes, sorry. I need something to let me know not to go past that point. I'll find out later. Okay, so that's my first curve, my sine of x. My next curve is x equals 0. So that's right here. So my graph won't go past that point. My next curve is x equals pi. That's right here. And then my next curve is y equals 2. So this is my enclosed region. Everybody see that? Cool. So now I have to take the volume, and my equation for volume, that is also on this little thing I'm going to post. Disk washer method around the x-axis, so it's going to be going this way. I'm going to be using the washer method. Disk is the same thing, it just doesn't have a hole in it. Washer just has a hole in it. As you can see, this little white space, it has a hole in it. So I'm going to be using my washer method, which is my outside radius minus my inside radius. When you're using this method, your radius should be perpendicular to the axis you're going about. Cool? So this is my outside. This is my inside. I determine my outside same way as I determine my radius for like when I was doing area or anything, top minus bottom or right minus left. So in this case, it's top minus bottom, and this is my equation for volume. Let me just put a V. V equals pi times my outside radius, top minus bottom, 2 minus 0. So that gives me 2 squared minus top minus bottom, sine squared minus 0. So that gives me sine squared theta. Oh, sine squared x dx. Clear? Cool. Then I just simplify. Oh, my bounds. I find my bounds. Because I know my function is in the terms of x, my bounds also have to be in terms of x. So it goes from 0 to pi because that's how far, that's the bounds of my graph. Clear? From 0 to pi, so from here to here, because it doesn't go past there. And then I just evaluate. I'm going to split these up. So I get, just makes it easier for me sometimes if I would like to split them up. I'm going to leave out the pi for now, but I'm going to put it back in. So remember that. Don't forget that. If you don't like leaving out the pi, don't leave out the pi. But that's just so I don't confuse myself. Squared x dx. But using my identities, I know my sine squared also gives me Oh, I didn't write this one down, but I will. So my sine squared theta is also equal to 1 minus cosine 2x. Okay? Yes. Can somebody, okay, yeah, I was gonna say there's something wrong. Okay, yeah, so that's it. But just for safe measures, can somebody double check that for me real quick? But I believe that's right. So 4x, that's my integral from 0 to pi. All this is going to be times pi. Oh. And then minus 1/2 minus cosine 2x dx. And then my integral of that. Four x is 1/2 times x minus 1/2 sine of 2x. Clear how I did that? This is the integral of that. So we know the integral of negative cosine is negative sine, and then you have to bring out that 1/2 from in the center. Yes. Oh, sorry. Any questions? And then you just go through and evaluate, and you'll end up getting 4 pi squared minus pi squared over 2, and that gives you 7 pi squared over 2. Yes, this was the identity. Sine squared theta equals 1 minus cosine 2 theta times 1/2. All right. Up. Okay, so where can't I pass? I'm gonna put a little sticky note right there. So don't pass that point. All right, so I will never pass that point again, okay? Any questions before I move on? Cool. No room. Oh, we are at 3. Gotta move a little faster so we can get through all of this. So the next problem says, given x equals 4 plus 2 cosine t, y equals 3 sine t minus 1, for t is less than or equal to pi over 2 to t 2 pi, eliminate the parameter to find the Cartesian equation, sketch a graph, indicate the orientation, and label points and t values on your graph. So basically, your Cartesian equation just needs to include x squared and y squared. Okay, we'll just keep going. And then I'm going to have to put the second part online for you guys. Yeah, I'm just going to put that second part online for you guys. Ooh, sorry.
What was the answer to the last one?
We didn't finish about the y-axis. But the answer to the first part, was 7 pi squared over 2. But we did not finish. That's my bad. So now we have to go about the y-axis. So this was about the x-axis. X-axis. Now I have to go about the y-axis. All right, so looking at, I'm not going to draw the graph again because that's a little much, but looking at this, if I try to go about the y-axis and I try to find like my outside radius, inside radius, it doesn't work because from 1 to 2 or from 0 to 2, I'm like running into all different kinds of equations. Do you guys see that? So then it goes to having to use the shell method. The shell method equation, it's getting really messy up here. Shell method equation is this, 2 pi times your radius times your height. So from here, this is my height. The height of my solid is this, right? So let me double check myself. Oh, no. This is my height. Because that does not count. So from going all the way across, I'm always hitting the same 2 curves, 2 and sine x. So therefore the height, therefore the equation for my height is 2 minus sine x, as I said, 2 top minus bottom. Now I have to go to my radius. My radius is always going to be the same thing, right minus left. So it just so happens that this time my radius is just x because my x varies. So I'm just going to put x minus my left is 0. Now, if I were to say, if this were to say about the axis x equals -1, and I had to go from here, my radius would be from over here to here. So then I do right minus left. So it would be x plus 1, x minus -1. You see that? Clear? All right, just wanted to make sure. But in this case, pretty easy. It's right minus left, so it's just going to be x. I gotta stop doing that, sorry. So I have 2 pi x1, x2. This is my equation. And in this case, it's dx. My x's continue to be 0 to pi because, as I said, my integral is in terms of x times, as we said, what our height was, 2 minus sine x dx. Okay? And then we just go through and simplify. So I'm running out of room. I'm writing so big. 2x minus x. I'm just going to split this up. And as I do when I split it up, I just circle that so I don't forget it. X sine x. That looks like a u sub. That's x squared. U equals so UV what did I do? Oh. Plus. Negative, so I'm going to put that outside of cosine x, and then that gives me sine x. Plus c. No, not plus c. This goes from, and then once I plug in my pi's, I'll get 2 pi, and this is after simplifying, 2 pi squared. Any questions? Everybody see what I did there? All right, cool. Now we can go to number 3. So number 3, oh, I read it out already, but we just have these equations, and they're asking us to turn it into Cartesian equations. Cartesian equations, as I said before, just in terms of x and y. So the way I do that, I know that x squared, oh, nope. We can just do this, and I'll tell you guys why I'm doing this in a minute. Cosine t. So y plus 1 over 3 equals sine t. So for this, I want to turn into a Cartesian equation. I know that sine squared t plus cosine squared t equals 1. So then I just square those, and that gives me x minus 4 over 2 squared plus y plus 1 over 3 squared equals 1. Just that simple. This problem isn't going to stop right here. As I said, I'm going to post the rest of the solution online when I post like the cheat sheet and all that stuff. But there's going to be, we're going to sketch the graph, indicate the orientation, and label the parts in t values. So I'll have an explanation of all that when I post it. So please make sure to visit that website. I'll write it down towards the end of this session. But yes, that's number 3, part A, I guess you can say. 4A, or 4. 4 asks us to find an equation of the tangent line for x equals 1 minus cosine t, y equals 5t secant t at t equals pi over 3. So this one, yes, I'm going to post that online because I can't. Yeah, I can't. No, you're fine. You're fine. You're fine. I just won't be able to do it at this moment. Sorry about that. But I'm going to, because I didn't do it in here, I'm just going to post a thorough explanation. So finding an equation of the tangent line. This is what's given to me. Okay. So we all know like our tangent line, all that great stuff. That's also on here. We have to turn it into a parametric function, dy dx, and the second derivative, all that stuff. These are the equations that we use because of our parameter that we have. So I have to do x prime, which gives me sine t. Y prime gives me secant t, tangent t. Wow, why did they use t? That's stupid. Okay. Then I just go through and I have to do dy dx because to find a tangent line, my equation has to resemble this. We should remember this from earlier on in our math, but this is what our equation has to look like. But we have to find this m, or let's just underline it. We have to find this, which is going to give me dy dx. So that is, what did I do? I did something wrong. It's okay. Sorry, give me just a second. The derivative of secant is secant squared t tangent t? Uh-huh. 1 over sine. Okay. Oh, just trying to figure out my mistake, really quick. My mistake. 1 over sine equals cosecant. 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 1 over sine It's okay.
Oh, so it's 5 t secant t, it's not 5 plus.
5t secant t,
Yeah, you wrote the equation wrong.
right here.
Yeah, it's not 5 plus. It's 5t times secant t.
Oh, no, that's a plus. That's just the way I wrote it. I'm sorry. That's,
Yeah, I'm saying in the online, the paper, it's 5t. It's not a plus.
really. Oh, I'm looking at the paper that I posted online too. That's a plus too. This is just the way I wrote it. That's my fault. But those are the right equations. I'm just trying to figure out what I did. A math mistake. Okay, so I'm just gonna go through, do it the old-fashioned way. So dy dt times dx dt. It's also the same as that divided by it. Okay, so we're just gonna keep rolling with this. So I have secant tangent, the derivative of secant t is tangent squared. No. I think I'm good. Okay. I'm like messing myself up because I have two different things. Yeah, that's what we have to do, but right here I have something totally different, but I think I made a mistake on my key than I did right here, so I'm like redoing it and realizing my mistakes as I go. So that's my fault. Don't listen to me. So secant t is 1 over cosecant. Cosine. All right, so let's just go ahead and do this, right? Let's take pi over 3, that's a 60-degree angle. So that gives me square root of 3 over 1, 2, and we're just gonna go ahead and plug in our t. So I know my tangent, sine theta over cosine theta. That's right, correct? Somebody correct me. Tangent is sine over cosine. Awesome. Over sine. And secant is 1 over cosine? Yes. Whew. Okay, so I'm just going to put a square. And that cancels, so then I have 1 over cosine squared theta. My cosine of 60 is 1 over 2, and that gives me 1 over 4. No, that gives me 4. And that gives me 4. So I did it the right way the first time. I just did a weird math over there. So let's not think about that. So my m, which is equal to my dy over dx, is equal to 4. And then to get my y1 and x1, I plug in my pi over 3 to here. So I know my cosine pi over 3 is 1 over 2, and that gives me 1/2. So my x1 equals 1/2. Let me plug that in. My y1 equals 1 over 1/2, which is 2. 5 plus 2 equals 7. So then I go to get y minus 7 equals 4 times x minus 1/2. All right, sorry for my blank, guys. That was a really stressful moment. Clear, understand why we got tension. No?
Where did you get 4? Y is equal to 4. 1 over cosine squared equal 4.
Because cosine is 1/2. So cosine squared is 1 over 4. So 1 over 1 over 4 is 4. That makes sense? Can I go on? Okay. So number 5. Number 5 says, find a Cartesian equation for r squared minus 1 2 sine squared theta. Same thing, we just need it in terms of x and y's. You'll usually see, you guys have been seeing that I've been drawing out a lot of triangles. Usually works best because you can always double check and then go back and then find your sine or tangent, whatever you may need. So for this one, I have an r. So an equation that comes to mind when I want x's and y's and I have an r is this, x squared plus, yes? Sorry, no problem. An equation that always comes to mind when I have x, y's, and r's is x squared plus y squared equals r squared. And then knowing this, I can draw a triangle once again. If my x and y is this, then my r is that. All right. So that's kind of just, I'm just putting my x and y's there based off like the axis. Now, in my equation, I have a sine. So the sine, if this is theta, the sine of this is y over r. Cool? And this is just me trying to get as much information I can so I can work out this problem. But as I said, before I start a problem like this, I always draw a triangle. So if you need to do that, please do that if it helps. So evaluating this equation, x squared plus y squared, I know my r squared from the top equation is 1 minus 2 sine squared theta. And I also know that 1 minus 2, my sine squared would be y over r, but I don't want an r in my equation. So just over here to the side, y squared, r squared. But again, I know r squared equals x plus y squared. So it's really just going back and finding what works. So y squared over x squared plus y squared. Any questions? Okay. And then you just go on. I'm going to leave the algebra to you guys so we can go on. We have about 30 minutes, so I want to get through as much as I can. So I'm going to leave the algebra to you guys. And again, I'm posting the solutions, but you should end up with this after simplifying. All that's left is simplifying. That's what you should end up with, okay? All right, so number 6. Oh. It says, find the length of the curve for x equals sine squared, x equals t squared, x equals sine t squared, y equals cosine t squared for t from 1 to 5. Using the cheat sheet, again, arc length. This is our equation. I'll write it down. Dx dt squared plus dy dt squared dt. And we're finding the length for this equals sine t squared, y equals cosine t squared and then we just plug it in and solve our integral. Or take the derivative first and then solve our integral. 2t cosine t squared negatives t sine t squared. And then just plug in those in, and my limits are going to be from 1 to 5, or my bounds, whatever you'd like to call them. T cosine t squared squared 2t dt. Simplifying, you get 4t squared times cosine squared of t squared, plus 4t squared times sine squared t squared. Again, you see another equation in here. Both have 4t, so you can pull that out. Then you have cosine squared plus sine squared. That gives us 1. So it works out beautifully. 1 to 5 of 4t. T squared gives me 1 to 5 of 4t, 2t. dt, which gives me t squared from 1 to 5. So then I have 25 minus 1, 24. And that's my answer. Yes? Oh, I don't know. I'm assuming, who was your professor? It may be, because I know some professors did teach this, and all the professors usually do the final together. What I would say is, as long as you memorize this equation when it comes to arc length, you should be fine. It's just the square root of dx dt squared plus dy dt squared. I'm not sure. I haven't seen the final, but this. Just ask if you want to ask to be clear. You can do that, but if they say yeah, definitely learn this equation. But it's just as easy as we went through it, as long as you know the equation, and because they'll give you these. So you just take the derivative, plug it in. Cool? All right, any other questions? Yes. The sine and cosine. From my identity, I know that, okay, so both of these share 4t squared. So if I pull that out, then I just have cosine squared plus sine squared, and that equals 1. So then it'd be 4t squared times 1. Any questions? Other questions? All right, so we're going to move on. What's this? Oh, it's not right. To number 7. I was organized until now. All right, number 7 reads, for which values of t is x equals t squared plus 1 and x equals et minus 1 concave up. Concavity, everybody's favorite. Hey guys, psst. Hey, psst. Front row. I can kind of hear y'all. Sorry. Thank you. All right. So I need to find the concavity for these two curves, and we'll get to that. It's fairly easy, not as threatening as it seemed. I know when I first learned it, it was very threatening to me. So to find concavity is basically you're finding your inflection points for the second derivative, and then seeing where these points are positive or in between these points where it is positive and where it is negative. So my first derivative, as I said before, when you try to find your second derivative of parametric equations, it's not just as easy as going deriving once and deriving again. You have to use those beautiful equations that I showed you earlier and that I will show you again. All right, so x prime is 2t, y prime is et. So my dy dx is going to be y prime over x prime, so et over 2t. And then the second derivative of dy dx is d dt. The first derivative, the derivative of dy dt divided by dx dt. Okay? Or you can just do the quotient rule for this, low d high minus high d low over low low. But that's the former way to do it. But I'm just going to do it the way I know how, the quotient rule, as you guys should know as well. So 2t t times et minus high et times 2 over 2t squared. And that is going to end up, after simplifying, giving me, because all these 2's cross out, and then I'm just going to take this et and do t minus 1 over t squared. Oh, wait. Oh, that's 4. That's why. Two. Hold on. 4t squared. I did something wrong, so I'm not going to do it this way, so I don't confuse myself. I'm going to do it the former way. The formal way. Okay, so the derivative of dy dx is et divided by dx dt. All right, I just did something wrong once again. Right now, not on my key. We're just going to do quotient rule. Low d high 2t minus high d low 2t. So that gives me 4t squared.
Oh, because you have 2t instead of 2.
Where?
On the right, minus high d low.
Right here?
Or down when you're double.
I'm not seeing what you're saying.
So like minus e to the t should be minus 2 instead of 2t.
Minus 2 right here?
Yeah.
Oh, you're right. You're right. Yes. Oh, this is the derivative of dy dx. That's where I'm wrong, not dy dt. So I'm going to have to change that on this. So that's where, after erasing for the third time, that's where I messed up. Okay, so you do the quotient rule. So it turns out, no, you cannot do the quotient rule for this, because you kind of, it's a little wrong. So you have to do this. So the derivative of this, then that's when you get, and I made that mistake too, so I'm not going to do that again. Low d high minus high d low, and that gives me 4t squared, low, times, or divided by the derivative of x, so dx dt, and that's going to give me 1 over 2, multiplied by 1 over 2t. So now I have these 2 cancel out, and that gives me a 2 at the bottom. I have e to the t times t minus 1 over 4t cubed. That's right. All right, so now I have to see what makes this equation 0 or non-existent. The only thing that makes this equation 0 would be 1, because if I plug in 1 for t, that takes that to 0, and 0 multiplied by everything is 0. Only thing that makes this equation non-existent is 0, because nothing at the bottom other than that can make it 0. Does everybody see that? Okay, so t equals 0 does not exist. T equals 1 makes 0. So now these are my inflection points. I'm just going to write a little graph. 0 and 1, and I'm going to plug in points, obviously not my inflection points because I know what it does to my second derivative, but I'm going to plug in points and see where it makes, or do I put it in my first one? And see where it makes it positive, negative, and things like that. So here I'm just going to use -2. I'm going to use 1/2 for this, and I'm going to use 2 for that. So when I plug in -2 into this equation, I get, am I using the wrong equation? Hold on, guys, give me just a second. Oh, okay. When I plug in -2 to this equation, I have a negative on top, but when that negative is cubed down here, I still have a negative. So this whole equation is positive. Negative divided by a negative is a positive. Does everybody see that? So then I'm just going to write that with a plus mark. When I plug in 1/2, I get a negative on the top. I get a positive on the bottom. So a negative divided by a positive is still a negative. So that's a negative. When I plug in 2, I get a positive on top, that's 1. I get a positive on the bottom, that's positive. So in between these inflection points, on the left of my first inflection point, it's positive. In between my 2 inflection points, it's negative. And on the right of my last inflection point, it is positive. So the question asks, where is it concave up? It's concave up wherever the second derivative or the inflection points, whatever numbers cause it to be positive when you take the second derivative. So concave up for -infinity to 2 and, not to 2, excuse me, to 0 and 1 to infinity. Clear? So I'm just going to put for positive. All right, number 8. How much time do we have? Not much. So I'm going to have to move pretty fast. So number 8, it says sketch this and find the area inside of R squared and outside of R2 and R1. So my R1 equals 3 minus 3 sine theta, and my R2 equals 1 plus sine theta. So this one is it's just like when we start graphing our polar equations. I will show you guys how I graph it, and if you have any questions, let me know. So from the way these are set up, you should know kind of what they would look like based on the equation. What is it? A cardioid? Right? Cardioid. So it's these two are cardioids. And then to find kind of, I just do this before any equation. When I graph it, I just find where they intersect. So 3 minus 3 sine theta equals 1. You set them equal to each other. To get 2 equals 4 sine theta. So sine theta equals 1/2. And I know my sine theta equals 1/2 at theta equals pi over 3. Okay? And this is like a little graph that I draw myself to graph my points. R1, R2. So I want to know what both equations look like when my theta is 0. So when it goes across this right here. When theta is 0, sine is 0. So this equation is 3 for R1. For R2, this equation is 1. That's pretty close, but oh well. For pi over 2, because this is pi over 2 right here, this is 3 pi over 2. Yes, 3 pi over 2. No, it's not. It's pi. And this is 3 pi over 2. Basically, just following my unit circle. So pi over 2, when sine is pi over 2, that gives me 1. When sine is 90 degrees, that's 1. So then that's 2. And then I'm just gonna go through because I already have them written down, but you guys should get the gist of what I'm doing by now, right? 3, 1 over 2, 6, 3, I did something wrong, but I'll fix it. 3, 0, 3, 6. So that's what your little graph should end up looking like when you're finished, and then you can just go through and graph it. And these, you know, your points are going to be identical for a cardioid on the opposite side. So that's just how I got that. That's 6. That's really bad, but. All right, so the problem asked, find the area inside of R2. So this is my R2. And this is my R1, inside of R2 and outside of R1. So this region right here. On the little cheat sheet, I'm going to post the equation. The equation for area between polar curves is this: A, B, 1/2 R squared theta. That's your area. D theta. Sorry. All right, so my R squared, again, is my radius. I'm going to take this, instead of going the whole thing, to make it easier for my bounds, I'm just going to take it from, we know these intersect at pi over 3. So right here, which is why we found this. I'm going to take it from pi over 3 to pi over 2 and then multiply it by 2, because these are both the same. It's just on 2 different sides of the axis. Yes? Huh? I don't think so. Let me draw my thing so I'm not tripping. 60. Yes, you're right. It's pi over 6. My bad. Thank you. So pi over 6 to pi over 2, and then I'm just going to multiply it by 2, okay? But you'll see when I go to multiply it by 2, there's a 1/2 in the original equation, so that just cancels that out. And my radius, as always, is top minus bottom, so it's going to be this squared, R2 squared minus R1 squared. Huh? Two times 1/2 from pi over 6 to pi over 3. 1 plus sine theta squared minus 3 sine theta squared d theta. Okay, and the rest of this, because we don't have much time and I really want to get to like Taylor series and all that great stuff, this is your integral, nothing else other than deriving or integrating, okay? Clear? As I said, solutions will be posted, so don't worry about it if you mess something up. Now let's go on to, did I skip 8? Was that 8? Yes, that was 8. Let's go on to number 9. Does the series converge or diverge? And this is where you're going to have to use different tests. This is something that this is a sheet that my professor gave me a long time ago. It basically just gives out the different tests and their rules. I'm going to post this as well. It was extremely helpful for me. So it just tells all the tests and what they have. This will be on the website. So I'm trying to put a lot of tools on there for you guys so you guys can be prepared by Saturday. Is your exam, right? Be prepared by Saturday. So number 9, we're finding whether it converges or diverges. Equals 2, 1 minus n squared, n plus 5n squared minus 6. So this one's pretty simple. Using divergence, I see looking at it, I can just use the divergence test because if I take the limit, I can get rid of this n squared on top. So I'm going to take the limit as n approaches infinity and just divide everything by n squared. So 1 over n squared minus 1 over 1 over n plus 5 minus 6 over n squared. As I plug into infinity, this goes to 0. That says it's negative 1. This goes to 0. That goes to 0. So then I end up with negative 1 over 5. The divergence test says if it does not equal 0, it is divergent. So it is divergent by the divergence test. Any questions? None. All right, cool. So B, I have n equals 1, 5 2n over n to the factorial. This one, I see I have an exponent, I see I have a factorial. I'm just looking through what your different test is. You can either use the ratio or a root. More than likely, you want to go ahead and use the ratio for this one. And the ratio test says you have to take an plus 1 over an and then solve for it. And if it is less than 0, it converges. If it's greater than 0, it diverges. Here. Oh, you have to find L. If L is less than 0, it converges. If L is less than 1, it converges. If L is greater than 1, it diverges. And if L is equal to 1, the test did not work and we have to try another one. Okay? So let's go ahead and try this ratio test and see what it gives us. So an plus 1 is 5 of 2n plus 1 over n plus 1 factorial. Divided by, I'm just going to go ahead and multiply it. N factorial over 5 to the 2n. That 2n cancels out. I know n plus 1 factorial also equals n plus 1 times n factorial. So then this cancels out, and I can get rid of that factorial. And then I just end up having 5 over n plus 1, right? Excuse me. Oh, plus 2, yes.
So when you were transforming into n plus 1, it wouldn't be 2 times n plus 1?
It would. That's exactly what I was just about to correct because I realized I made that mistake. So it's 2 times n plus 1. Do not make that mistake. Don't be like me. So it end up being 2n plus 2, and that cancels out. So it'd be 5 squared, which gives us 25. And now I have to take the limit as n approaches infinity. So the limit of n approaches infinity of 25 over n plus 1. This blows up on the bottom, so this ends up going to 0, which is less than 1. Therefore, it converges by the ratio test. Clear? All right, cool. So let's move on. Oh, my fingers. Number 10. Does a series converge on the website? I'm going to have to repost this as well because I forgot to put the equation that you needed to find whether it converged absolutely, conditionally, or diverge. So this is the equation, but I'll write it again up here. So number 10 is incomplete for the version on the website. So it's asking us to find, basically solve like absolute convergence or whatever. Negative 1n, n squared over 3n squared plus 7. When you see this, when you see that negative 1, your mind kind of already automatically goes to trying the alternate series test. So that is what we're going to do. The alternate series test says basically to take the absolute value. Oh, to find your like bn plus 1, take the limit and see is it less than your bn. So let's go ahead and do that. My bn, taking out this negative 1, is going to be n squared, 3n squared plus 7. Then I'm going to take the limit of this bn this bn, and divide everything by n squared. So that gives me 1, 3 plus 7 over n squared. And this goes to 1 over 3. Oh no, I'm going to divide everything by n cubed, because that's a 3n cubed, not a 3n squared. I wrote that wrong, sorry. So I have to need to divide everything by n cubed. That leaves me with 1 over n times 3 plus 7 over n cubed, and then that goes to 0. Once you take with infinity, because that blows up. 1 over n blows up and goes to 0. All right, now I need to find my bn plus 1. So n plus 1 squared over 3 times n plus 1 cubed plus 7. This is my bn plus 1 is indeed going to be less than my bn, because the bottom increases faster than my bn. Does everybody see that? All right, so therefore it converges by AST. Now I'm going to use a different test. With this one, let's go ahead and use the comparison test and see how far we can get using that. I'm going to compare it to, I'm going to compare it to this, or not this, but to this, and just take out that plus 7. 3n cubed. My comparison test says, this is what my comparison test says. My bn, so this is my an, and this is my bn. My bn is greater than my an, but this says if bn is greater than an and bn converges, then an converges. But we know that bn does not converge, because when we simplify bn, we end up getting 1 over 3n. And if you take that and make it look something like this, that's harmonic. Harmonic diverges. So therefore, it doesn't converge. We can't even use that. But the limit comparison test says if you can't use the comparison, then you can take the ratio of those two. It doesn't matter if it's an or bn over an. It's just given an over bn right here. But if you take the comparison of those, or the ratio of those two, and you end up getting a finite number, then they behave the same. So however they behave, whether it converges or diverges, the an behaves the same, right? So let's go ahead and do, for ease, my bn over my an, and I'm hoping I get a finite number. Squared over 3n cubed times 3n cubed plus 7 over n squared. Okay. So that goes away. And that gives me 3n cubed over, I'm just going to go ahead and split this up so I don't confuse myself. That gives me 1. I shouldn't have scratched that out. Anyways, that gives me 1. So the limit, what time is it? As n approaches infinity of 1 plus 7 over n cubed, that goes to 0. So the limit of it is 1. 1 is a positive finite number. Therefore, if my bn diverges, then my an diverges. So by the limit comparison test, it diverges. So therefore, it is conditionally convergent. Because with one test it converges, with one test it diverges. Clear? So I'm going to underline that, and in big letters, conditionally. Any questions? Yes. To find absolute, I believe that's when I use the AS. Oh, no. For either one, you can't, it's not like absolute, because it either shows absolute convergence or like divergence. But if one were to find absolute convergence, then that would be it. So I used two that would show either convergent or divergent. One showed convergent, one showed divergent. Cool? Any other questions? Okay, so it's 12:15. I said I'd give us 15 more minutes, but I really want to get to try to explain a Taylor series with you guys. So 5 more minutes, and then I'll take 10 for questions. And if we don't have questions, then I'll just keep going. What am I on? 10. Okay, so 11 is use integral test. We won't do that yet. Find the Fourier formula. Okay, so I'm going to do a quick Taylor series, and then I'm going to go back and go over this other stuff. All right, so this is number 15. If I'm not mistaken, I believe I numbered it wrong on the one online as well. So this is just the one that says find the Taylor series for f of x equals ln of x minus 1 centered at 2. So I want to say a equals 2. This stuff is crazy up here. All right. So on our cheat sheet, Taylor series, you set it up like this, and this is what you use to expand it. So this is the equation that you're always going to use every single time for Taylor or Maclaurin. The only difference for Maclaurin is it's always centered at a. So it would just be x to the n instead of x minus a to the n, okay? All right. All right, so I just got to go ahead and set up my graph. Or I'm not really going to set up a table. I'm just going to go ahead and go through. But if you have any questions, please let me know. You can't see? Okay. So just go ahead and go through and take the derivative. You get x minus 1 to the negative 1. You get negative times x minus 1, negative 2. 2x minus 1 to negative 3. X negative 6, x minus 1 to negative 4. Most of the time you really don't have to go this far, but this is just like a just in case. And then you find your equation with its center. So my center is a equals 2, so ln of 1, which gives me 0, and then so on. Okay, so now I'm trying to find the pattern. So then I use the equation that I showed you guys here, and I go on and I write it out. My first equation is 0 over 0 prime times x minus 2. You really don't have to do that, but it's just for safe measure. Can you see? All right, and then I have, let me write the equation on the top, so I have to keep looking. N prime, n. This is our Taylor series equation that we're using to expand it. So now I have 1 over 1 prime times x minus 2. 1 minus 1 over 2 prime x minus 2 second plus 2 over 3 prime times x minus 2, 3, and so on. I'm going to stop at this 6. plus dot, dot, dot. First thing we see when we want to set this up is that it alternates. So when it alternates, you already know that you need to put a -1 in. Now later you'll find out whether you need to put whichever you need to do for that exponent, but we'll get to that later. Also, we notice that in every one, we have x minus 2. So x minus 2 in. And we see that because when x minus 2 in is 0, we get that. When that's 0, we get that over, over n factorial, yes. So just to double check this, when we plug in 1, we get this, but that gives me a negative. But I don't have a negative right here. I have a positive. The only thing that can make this positive is if this exponent is positive. So I know I need to add a 1 to that n plus 1. To that n. You see that? So every time I add a positive number, it gives me a positive. Every time I add an odd number, it gives me a positive, which gives me a positive equation. Every time I add an even number, it gives me an odd. So on my odd numbers, I'll have negative. And that is my Taylor series for that. Cool? Any questions? No? All right, so like I said, I wanted to go through that one and take questions because we have about 9 more minutes. Any questions, period? None. Yes?
I have a question about what we just did.
Okay.
If you plug in 0,
Uh-huh.
are you not supposed to be getting, you're supposed to be getting 0.
If you plug in 0, you should just be going ahead. You should just get what your first expansion was.
But when you plug in 0 for that, then you get 1.
When you plug in, not necessarily, because for this or for this?
For the series that we made.
For this, you should get 0 because it'll end up being the same thing. So that's going to be -1 times x is 0. Anything to the 0 is 1 over 0 prime. Over 0 factorial. So that just gives you nothing. It's just there.
I thought 0 factorial equals 1.
Oh, I think 0 factorial does equal 1. That's a good question. You don't necessarily have to start it at 0. That's just how I do it. But I do know once you plug in that 1 that's there. But in a way, these should end up giving you this 2 same ones. So I would have to look into that and then post that on the solution. Yes? In -1 factorial? No, because when you plug in 1, you get x minus 2 to the 1 over 1 factorial. Right here? I'm not getting it. You mean like right here?
No, like you see how it's 6 times x minus 2 over the full section. 6 times that. Yeah, right there.
Mm-hmm.
Isn't that n minus 1 factorial?
No, because when I plug in my 4, that gives me, all right, so if I were to say, what's the 4th series? Because this is my 0th term, this is my 1st term, this is my 2nd term, this is my 3rd term, this is my 4th term. If I say, what's my 4th term, that's when n equals 4. So when n equals 4, this is 5, so that gives me -1. This is x minus 2 to the 4th, and then this is 4 prime. Not 4 prime, but 4 factorial, which matches this perfectly. Oh, the 6, the numbers, yes. I completely forgot about the constants. On the top, is that what you're saying? Let me see. If you have 0, so if it's n minus 1 factorial and I put a 2, then that gives me 1, yes. If I put, why did I put 2 cubed? That's just 2. If I put 3, if I put 4, that gives me 3. Yes, it is. Sorry about that. Thank you. So don't forget about your constants as I just did. I almost did that in the next problem we're probably about to go over, but don't forget about your constants. So thank you. Any questions before we move on? Any questions about anything? This is the time to ask. All right, so I guess we'll keep going for the next 5 minutes. So I'm just going to kind of like scurry back. If I can find. So we did a lot of, yes.
So if you add the exponential factorial, so we're doing for the first term is 0, what's like the factorial of negative?
Factorial for -1, it'd just be -1 times 0, if I'm not mistaken. Because you're just going down, yeah. If I'm not mistaken, but I'd have to double check that. Real quick, okay. We stopped at 10, was it? All right, so real quick, I'm just gonna show you one for the integral test. So we're just gonna go through the keys since we're short on time. It says use the integral test to find divergence for this. Or you can see that. Basically what we do, because we can't use any other test, use the integral test. Oh. So using the integral test, we have to test for positive, continuous, and decreasing. It's positive because from the function goes from 2 to infinity. So from 2 to infinity, it's never negative. Do we see that? Cool. So for it to be continuous, the only thing that can make this discontinuous is 0 because of this thing right here. Clear? If this weren't here, it'd be anything less than 0 or anything less than 1. But because this goes from 2 to infinity, it's continuous from 2 to infinity because everything from 2 to infinity makes it continuous. It's decreasing. The way you find it's decreasing, you take the derivative. Oh, no. You take the derivative and then you, if the derivative is negative, then it's decreasing. Clear? All right. So then you just go on and do the integral test, which is basically when you have to set the equation up in an integral. Of course, sub your infinity for b because you can't take the limit and take the limit as b approaches infinity. And when you take that integral and you plug in, or you take the limit as b approaches infinity and it equals 0, or you get a number, a constant or a finite number or whatever, then it converges. Cool. Number 12. This is just me going through this pretty quickly because we have to wrap up in like a minute. Number 12, find a formula for the general term. This is what you use for that. This, your geometric series function, 1 minus x, always, and that equals the summation from n equals 0 to infinity of xn. So I'm finding the general term, for this sequence. So through here, through this, I see it's alternating. So positive, negative, but on my odds, so my first term is when it's positive. So it has to be n plus 1, -1 n plus 1. Do we see that? It also increases in the numerator by 1. So it's just going to be when my first term is 1, then my numerator is 1. When my second term, my numerator is 2. My third term, my numerator is 3. So that's going to be n. On the bottom, it increases by squared. So 5 squared, 5 cubed. It's not, you know what I'm talking about. 5 squared, 5 cubed, 5 to the 4th, and so on. Okay? So then we just end up getting that. Oh, I think I just showed you 2 different equations, but that's okay. Power series, that's what I was trying to show you. You use the geometric function for power series. When you get to that, it's going to look like this. So basically, you have to make it look like this form, any way possible, any way you can. And so to do that, you can take out this 1 over 9, and then you end up getting this 1 over 1 plus x squared over 9. Then to simplify that to make it look in a sort of way like this, to get the ratio, it's 1 minus, because there has to be a minus, negative x squared over 9. Any questions? Cool? All right, so then we know this is our ratio. And the way to set this up is just to set it up. That's all you have to do every single time. The summation of negative x squared over 9 to the n, and then you just simplify that. So this negative 1 to the n, this x to the 2n, and then there is then it's 9 over 9 to the n, but when you pull in this 9, it's 9 to the n plus 1, because 9 over n plus 1 is the same as 9 to the n times 9. We see that? Cool. Second one, what time? Ooh, past time. Last one. Second one, same thing, except you have this in the bottom and you can't really separate that because that function is squared and you have an x at the top. So the way to decrease that exponent right there is to take the integral. Sometimes you have to increase it and take the derivative, but this time you have to take it and do the integral. And you do the same thing, as you can see in the one before. We already found our function. It's the same one, 1 over 9 plus x squared. You just have a negative 1/2 that I took and put on the outside. So you take that same one that we did in the previous problem and plug it in, but because you took the integral at the beginning, you derive when you get to that, and that gives you that. Yes?
Back to the question 4 over 9. Where's
The answer is right here.
Oh, okay.
Okay, cool. So you derive with respect to x. One thing I found myself messing up on, I derived every single n. Do not do that. Only derive with respect to x. So when you derive that, you subtract 1. You multiply it and subtract 1. So 2n times x to the 2n minus 1 in your equation, and that's it. Cool? As I said, we probably didn't get to go over about 3. We already went over the concepts, though. I'll post all the solutions and a thorough solution to the one that had like a part that we didn't get to go over, the graphing and t-values and all that. But other than that, you are done. Good luck on your finals. I hope you all do well. And make sure to look at Google, Study Union, WordPress. And you should find it. Oh, it's not up there. There it is. In about an hour. I gotta upload.